Hello and welcome to this video where I'm going to show you how to make procedural terrain in 3D this time. So if you're interested in 2D, 3D, no, 2D, 3D terrain, in 2D terrain using Perlin Noise, you might learn something about Perlin Noise in this video, but you won't learn how to do it in 2D. So I have made a video of how to do that in 2D, so you can go and find that. I've just realized I haven't started. Let's just pause this. I haven't started my little timer here. I'm not doing like a speed coding challengey kind of thing, but I did want to keep. Oh, I haven't started it. I did want to keep an eye on myself and make sure I keep this to about 15 minutes. So what are we after? We're after creating 3D terrain that's procedural. So that means it's a little bit random, but it means you can return to the same terrain if you've created like a really nice realistic terrain or whatever you're making, and you can use a seed to generate that same terrain again, um, or you can completely like kind of randomize it. But essentially, it's allowing you to create this kind of thing. So where you've got smooth hills or like rolling mountains, that kind of thing. And at the moment, I've got these guys moving. Actually, I can press space. I forgot. And now I've frozen this kind of terrain. So I'll teach you also how to do that. So I suppose if I press spacebar again, it looks a bit like the sea textured with like the ground or something like that. But I can show you how to do that. Maybe not this video. So in this video, what we want to do is work out how. And if I go to pause, by the way, if you're using a first-person controller in Unity and you've lost the cursor, you don't know where it's gone, just press escape and it'll appear again. If I just pause that, yeah, this view shows you basically what we're going to do. We're going to create a simple plane. So that's where you go to Game Object, Object Primitive, I think it's called. Anyway, you'll see it. And we create a plane which has got basically loads of points on it. You don't get to see those points. And in a plane, they're all kind of aligned and nice and smooth. And what we're doing here is simply raising those different points according to the Perlin noise. According to, if you're not sure what that is, that just means this kind of random stuff or pseudo-random stuff I was talking about at the beginning of the video. So each tile, each area like this, it has all these points on, and we're going to keep their X and Z positions the same, but we're going to lift their Y positions, or we could push them down as well. And we're going to do that according to that Perlin noise. So I'm going to start this from scratch. I've got my I've got something already set up here. So what I'll do is create a new scene. I better save that one. So I've just got a main camera and a directional light. I like to rename the sun. Let's call it Mrs. Sun. There we go, Mrs. Sun, and we'll make sure that she's nice and pink, so everyone gets annoyed. Right. Okay, we've got a nice pink sun. So what we're after doing is 3D object, create a plane. There we go. We've got our wonderful plane, and we want to be able to like generate this rolling terrain stuff. So create yourself a script. I'm going to work in C#. The same principles will work in JavaScript, so don't worry about that. If you really want me to, I can make it in JavaScript, just let me know. So let's call this make, well, let's call it The Hills Are Alive. The Hills Are Alive. I've just realised how sleepy I am listening to myself talk out loud, so I'll try and have a swig of tea, and I'll try and perk up a bit, go a bit faster. Right, so The Hills Are Alive. Let's open up our script. So we've got mono developer. You just saw my old version. Let's make this a bit bigger. Shift Command plus. There you go, you can see it. Right. So we've got our start function and our update function. And what we're going to do in the start function, so when this, we're going to attach this script to that plane that I made. Let's just go and have a look at him. In fact, let's do that now before I forget. So I'm going to apply this script to that plane. So if we click on that plane, yes, we've got the hills are alive script. And let's just call him the little ground. The little ground. There he is. Right, the little ground. So we want the little ground when it starts, when this runs. I don't think we'll even be able to see anything because the camera's pointing in the wrong direction. Oh, we can see him. Oh, look, that's a pretty nice view actually. So when we start next time, we want this script to actually do something. We want to get a hold of all these points, which are called vertices. You can't see them here; they're just virtual, and we want to then manipulate them. Right. So 5 minutes has gone by. 5 minutes of me introducing how we're going to do this. That's not too bad. Right, back to mono develop. So we were in the start menu. So let's call this function generate generate Perlin hills. Okay, so I've got to make this function now. It doesn't yet exist. So void generate Perlin hills, and now that should stop being red because it now exists. Okay, and we'll save that. So in here we are going to do the magic. So what we essentially want to get hold of is the mesh filter component, this component here. So I'm clicking on the little ground or our plane object, and I want to get hold of the mesh filter. Okay, right, let's do that. So first we'll create a variable to store this, and we call it my mesh filter, I'll call it, to help you remember that. Don't get mixed up with mesh and mesh filter. We definitely want the mesh filter. Okay, my mesh filter. Oh, we haven't told it what kind of thing we want. We want a mesh filter. Okay, there we go. Right, so in the start menu, what we can do is get a hold of that. So we want to say my mesh filter equals this component's get component. So all I'm doing here, this is how Unity gets hold of those components that are kind of attached to the transform to the game object. So this plane is a game object, and it will have a transform like all other game objects. And these are like additional bonus components, and we want to get hold of the mesh filter, not the collider. We'll come to you later, and we can leave the mesh renderer. That's how it looks until later. Actually, we won't bother with the mesh renderer at all. So get component, we want to get hold of the mesh filter. So not the mesh, but the mesh filter. And we actually want to get hold of the mesh itself. There we go. Let's just separate these out so you can see what's going on. Okay, so in my mesh filter is the mesh filter's mesh. There we go, we've got hold of that. Right. So then, what do we want to do? We want to basically make a for loop where we go through all of the mesh filter's mesh vertices, right? And a vertex is simply the name for this 3D point, or a point in 3D space. So we want to have a vector 3. So we want a vector 3 object, and we'll just call that vertices. And actually, we want an array. So to create an array in Unity, in C#, we use square brackets after the variable type. In this case, our variable type is a vector 3. And the name of our variable is vertices. I'm pluralizing it because there's a convention, if you're making an array in programming, in coding, name your arrays in the plural. So not vertex in this case, but vertices. It helps you remember that it's not just a one thing, it's got lots of things in it. So vertices equals my mesh filter dot vertices. So a mesh filter, the mesh belonging to the mesh filter will have its own array of vertices, and it's called vertices. Right, so I haven't made that up. That's always going to be attached to your mesh filter's mesh. It's going to have a load of vertices. Okay, so all we've done is store all of those vertices in this array. Okay, so now we can create a for loop. So we can say for int I equals, we'll start at 0. Dealing with an array in programming, you start at 0. And we're going to go while I is less than the number of vertices that we just got. So we get hold of that by the length keyword, and then we're just going to increment I. So now, in this for loop, we're iterating over, looping through all of the vertices that are on this plane. So all of those little vertices are on there. I don't know how many vertices there are. Let's let's just print that out. Let's just say debug.log, and we'll say there are vertices dot length plus vertices on the plane. There we go. Right, this should just print this out to the number of vertices to the console, so we can find out. I believe this will run already. It won't obviously change any of the ground. We're just grabbing the vertices if there are no problems. Right, let's have a look. Stop it, and we should be able to see in the console. So there's 121 vertices. So there's 121 little points on here, all in like a grid, making up like triangle strips that we can now bend and weave. Okay. I don't know why I'm getting that error down here. I'll try and fix that later on. Might be something to do with the window setup, the editor's window, I don't know. Right, wow, a lot of time has just disappeared. That was amazing. Last time I looked, I had 10 minutes. Right. So we're looping through our 121 vertices. And basically what we want to say is each vertex, we want to get hold of its y component. Remember, what is a vertex? It's a vector 3. That means it's just a point with an x, a y, and a z component. So to get hold of the x, y, and z components, you write the vertex that you're referring to. So I'm looping through all of them, and I'm getting hold of its dot y component. And I'm just going to say equals, and now I need a number. I need a number that the Perlin noise is going to generate for me. So I'm going to say mathf. This is how you get to the Perlin noise function. And you'll notice in here, the Perlin noise will take basically a coordinate, two coordinate parameters, an x and a y. And what we're going to do is, imagine our plane that we've actually created. In fact, don't imagine it, have a look at it. What I'm going to say is, each of these vertices is going to have a different position relative to its parent position, the plane's position. So they're all going to have basically different positions on the x-axis, which is the blue here, the red here, and the z-axis, which is the blue. And basically, we're going to feed those two components, those two coordinates, into our Perlin noise. And the Perlin noise from that will generate that pseudo-random pattern. That's all Perlin noise really is. It's a massive, great big picture of loads of hills already, or like a height map. And all we're doing is finding a position on that map and asking for the value at that point. And really, the Perlin noise will return a value between 0 and 1. So then we can scale that up to have different heights. So all we're doing with this Perlin noise function is putting in two coordinates. So we can, if we know those coordinates, we can always find them again with a seed, as I was talking about it, earlier on. I've forgotten the point that I was explaining. Anyway, we're going to get a number between 0 and 1. So we want to put in, I'll call it a px for Perlin x and Perlin z, to remind myself I'm using the z axis. Okay. And then I'm going to time, no, I'll just leave it at that. Leave it at that. No, I can't really. I have to times it by, we'll call it the height. Times it by the height. So I need to go and make that variable. 30 seconds of our 15. So what should I do? I think I'll do I stop and upload, or do I just keep going? I'll keep going. I'll keep going. Why not? Okay. Oh yes. So we need to make our height. So let's make a public variable. So then we can set this from the outside. So I'll make it a float height. In fact, it's really important when using these functions and things in Unity in C# to be careful when you're applying floats and when you're applying integers, floating points and integers. Sometimes these won't work if you're mixing in, especially with vectors. If you're trying to apply ints to where vectors are using floats, it might not work and you might kick out an error. So usually with maths, everything's going to use floats. So change everything to floats and that might iron out any bugs that you have with that. Okay. So we're going to set our default height to, let's say, it can be 5 meters high. So we're going to get from Perlin Noise, the Perlin Noise function, we're going to get a number between 0 and 1, and then we're going to scale that up to 5. So if we get the maximum value of 1 out, we're going to scale up that to 5 meters, and then that vertex will be, it's the y component of that vertex will be hoisted up 5 meters. Okay. We haven't got our px and py. So this is essentially going to be our coordinate. So float px equals 0. I'll just set them to nothing at the moment. Pz equals 0. Okay, so each vertex will have a different coordinate according on that plane, and we want to use that change to kind of map that onto the Perlin noise. So that's how we can get our hills and things. So we want to say px equals, first I want to find the location of our plane. So it's going to be this transform dot position dot x, and then we want to add to that the vertex position. So vertices I dot x on the x-axis. And then what we want to do is divide the whole lot by the amount of detail that we want to have. I might call it resolution or great. I think in my last video on 2D Perlin terrain generation, I think I called it the gradient. So I'll call it gradient. So the lower that number, that gradient, the spikier your terrain will be. And so we'll be able to play with that in a moment. So again, let's create a public variable for that. Gradient equals, and we'll set it to 5 is a good number as a default, I think. Okay, so now we just have to do the same for the px component that we're feeding into our Perlin noise, and accordingly we won't refer to the transform position x but transform position z and the z component of that vertex, and again divided by the gradient. Okay, that should do it. I don't know what we'll get if we actually run it. Let's have a look. Okay, let's see if this actually runs. Okay, so we're getting We're getting no hills, no valleys yet. Let's just have a look at what's going on. Okay. Part of me, I'm glad that that's happened, because this is usually what most beginners will experience when using Perlin Noise, this Perlin Noise function, for the first time. And you'll potentially spend a lot of time fiddling around with these numbers, which hopefully I won't do now. and it'll be very frustrating because you've done everything correctly, but it's not working. I know one thing I haven't done. So I've changed. I've changed each vertex that I've got in this variable, but I haven't actually applied that to the mesh. So what I've got to do, I've stored it. I've made my own array of vertices, and I've changed their y values. I haven't done anything to the actual mesh. So we have to do approximately 4 things here. So we have to get hold of that. We have to apply a collider. What if we want to walk all over it? We need to do that. So the main thing we need to do is say my mesh filter dot vertices equals vertices. Okay, so all we're doing there is simply we're copying all the new values. We haven't changed the x and the y values of the vertices on the plane. We're just manipulating the y values. I look like a puppet master, sorry, just catching myself in the internet mirror. So I wonder if that works already. So we haven't made it physical or anything, but does that change the renderer? Yes, it does. Okay, so we've now got it working. Fantastic. What would be really nice is if I just applied a texture to it. There we go. And brought the camera a bit closer. Can I just get hold of him? Yes. Put it in the center-ish. And maybe look down. If I rotate you down, have a look. Okay, so the only issue is if I press play, then the height of the thing might be too great. Yes. Okay, so let's just move the camera a bit more. I want to move up. Actually down there. Backwards, really. Okay, fingers crossed we'll be in a good position now. Okay, kind of. Let's I really need to apply a first person camera in here to have a good look. Well, actually, can I just pause it and have a look in the editor? Okay, so we can use the editor to have a look around. So there is our 3D terrain, and it's only applied to one tile. So if you're making a great big environment, and I might do this in the next video, is you would tile lots of these together, and you and the Perlin Noise, because it's making a reference to where the vertex is according to each plane that you're kind of making. There we are. So each plane's position on the x and z plus that individual vertex's position on the plane x and z, wherever you put those tiles in the world, they are kind of coordinated, working together in terms of the Perlin noise. So basically all your tiles will match up perfectly. So let me just stop this. Next thing we want to do is make sure the collider is working. If we created a first person controller, we would fall straight through the mesh filter, or we would fall through it onto the collider where the collider used to be. Doing this, copying the vertices, doesn't affect the collider. So what we want to do is get hold of the filter, and then we want to I've forgotten what to call it. There we are. Recalculate the bounds, and then we want to do very similar thing. Recalculate the normals. Okay, so that recalculates all the physics basically between and betwixt your vertices, and then what we can do is get hold of the collider. So in fact, should we do that? We should do that in start so that this runs a bit more efficiently. So private mesh collider, I'll just call it collider, my collider. There we go. And then in start, I wonder if I can make use of this old code. Copy and paste. So my collider equals this component get component mesh collider. Okay, lovely. Right. So now down here we can get hold of my collider, and what do we want to do? We want to I can't even begin to think. I don't want to look at my old code. I want to remember. That's it. We want to share mesh. Share mesh or shared mesh equals null. So first, this is important for being optimal in terms of speed and things. We just want to sorbet that that landscape of vertices and things. Okay, and then we want to reapply the collider. So now that we've got our mesh filter has got all these bumps and ravines and beautiful landscaping, we then want to like drape the collider over that. So to do that, you simply say my collider dot shared mesh equals my mesh filter. Do I have to say dot vertices? Or will it just use that? No, it would just use the mesh filter. That's all it needs, I'm sure. Okay. One last thing that I would like to do is in the update we can check for keys down. What would be really cool is if every time we press, say, the spacebar, we could kind of shift the Perlin noise along. So let's try and do that. I will say if input dot let's say get key up. So once we've released the key and we want key code dot spacebar, can I just write that? Space, brilliant. So if that happens, if I press spacebar, then I'm going to say seed plus equals 0.1, let's say. Oh, stair speed, what? Because I haven't made this variable yet. Seed plus equals 1, and then I want to, did I call it generate Perlin hills? Okay, so when I press the spacebar, I'm going to shift along this variable by 0.1, and then I'm going to generate the hills again. So to add the seed, we want to add it here. It doesn't matter whether you add it to the x-axis or the z-axis, as you'll see. And I'll show you how it works. Once I get this going, you'll see what on earth I'm doing. So first, let's just make a public float seed, and we'll have it start at 0. There we go. So let's get hold of the little ground. So we've got gradient, we've got height, and we've got seed. So at the moment, if I run it, I really want to stand back a little bit. Let's just sort out this camera a bit. Can I go like, I just need to raise it up, don't I, about 7? How's that look? Okay, we've got a good view of things. Right, now I'm pressing spacebar, and you'll see basically what we're doing is moving along the x-axis in the Perlin noise, and then we're applying that to our ground. So it might give you an idea just seeing this. I know for some people it helps you. Well, it manifests the Perlin noise right before your eyes. And that's fantastic. So you could apply that to create like an ocean, or maybe you have your player static and you move the world around them. That's the basics for getting that going. Seed. So you could start. Where's my little ground? You could start the seed on your birthday. Say, let's say you were born on Christmas, so 25th of the 12th. What year? That's the thing. 1984. Year of the robot. There we go. Now, if we look at this, that's quite a distinctive shape. That's perfect. You see this big like dip here. You see that big dip? Right, let's stop it. And we'll play it again. You see that big dip? Brilliant. That's because we started with the same seed. We've just added this, where is it? We have added the seed. That's the only place it works. We've just added it to where that coordinate is, the x coordinate that we're feeding into our Perlin noise. So basically, finding the position through the plane's position, the vertex's position, and then we're just adding a little amount according to the seed. So let's change that seed now. Let's say the seed is 12. See what we get. So very different. We get rolling hills. There's no 1984 dip in the top left-hand corner. You can still press space, and eventually we would find again that position. The Perlin noise kind of like pseudo-random, like abstract hills and things. Essentially, that's infinite. So you could use any massive seed that you wanted to, or maybe you generated something clever like or interesting. You could have you could put your name in, and you could convert that to numbers and then use that as your seed, or secret messages or anything you wanted. So there you go. So this is procedural. Well, not really procedural now. We'd have to kind of move around and generate using the same technique, the hills, depending on where the player was positioned. Right, I think I really need to stop the video here. So that's the basics of getting things going. In the next video, we'll create like a management system for making loads of these tiles together and kind of coordinating them. I want to do one last thing. I want to, let's just decrease the gradient to 2 and see if we get a spikier hills and things. There we go. So much spikier. And that's by affecting the gradient. So last thing I'll show you, just returning to this code. I guess I need to make this code available somehow. I'll try and put it onto GitHub so you can find it and put a link in the description. So how do you apply a gradient? Well, first you find the position of your vertex, and then you divide all of that by the gradient. You add the seed later on. Oh, by the way, the final thing I'll do, I'm now going to add the seed to the z-axis. And this is like your a question to test your knowledge. What's going to happen now when I press spacebar? How do you think the terrain will change this time? How will it be different? So send your answers on a self-addressed postcard or whatever. Let's find out the answer. Okay, press space. There you go. If you thought, yeah, we're going to have movement on the other axis, you were completely right. So now we're moving the Perlin noise according to the z-axis, which is like going towards us. Okay, right. Thank you very much for watching. I'm sorry for being a little bit dopey, a little bit sleepy. But there you go. Perlin noise in about 2 hours. Brilliant. Right, stop the video. Goodbye.